Hi, my name is Luke, and I'm a chemist in the Institute of Geological Sciences, Polish Academy of Sciences. I got this idea to run us basically because, as far as I know, there's plenty of sources in the internet that are oceans of wrong, false information about minerals and mineralogy, Wikipedia included, but also many internet websites. Although they do bear information in this, so plenty of errors, which people kind of repeat what I hear in the society, as I say. So my idea was to undermine these false foundations, so this false informations. To begin, what I want to say is that this is quite often observed, for instance, among some chemists. Some people do not believe that actually mineralogy is a separate science, which is obviously wrong. If you go to the history of sciences, disciplines, and you get this idea that mineralogy is actually older than chemistry, and as such constitutes kind of introduction to chemistry. We also have to remember that without minerals, which are ores, or rocks, which are also sometimes ores, there would not be chemicals. I assume that at least some of you might be acquainted with lab growing of crystals. If a crystal, which is the first part of the definition of mineral, it must be a crystal. However, if a crystal is grown intentionally by a human, it is not a mineral. A mineral is a crystalline compound which forms naturally, which means that it forms without intention of human activity. Of course, there are situations, and there's actually plenty of them, where drawing a bold line between what is a mineral or what is not a mineral, what is a synthetic compound, it's uneasy. It's not that easy. And it is also important to say that sometimes drawing such lines between, for instance, mineralogy and chemistry is not useful, especially that mineralogy and chemistry, of course, do have a lot in common. And basically, what is the most important is that they're connected via this sub-discipline of chemistry, which is known as crystallochemistry. So this is basically a science which is dedicated to the way the atoms are being set in the space, internal space of the crystal. Of course, there are substances in the environment which do not form crystals, but they do occur naturally. A very good example of this is native mercury, which is liquid, at least at most conditions found on the Earth, and as such, it is called mineraloid. Mineralogy as a science is listed as a discipline or subdiscipline of geology. However, as it is true in the case of a lot of subdisciplines or disciplines even, mineralogy is quite interdisciplinary. So it is also related to physics, it is also related to geochemistry, for instance, and of course chemistry in general. What is also important to be said is that as you know, the rules in the chemistry of the nomenclature and systematics of the chemical compounds, it is governed by IUPAC, International Union for Pure and Applied Chemistry, and this is exactly the same in the case of mineralogy, where IMA, International Mineralogical Association, governs and gives the rules, constitutes the rules of mineral nomenclature and mineral systematics. What they do in the EMA, they basically try to clean the mess that was basically brought up mostly in times before the constitution of the EMA, which is now very old formation. And so, as you can see, there are some very direct rules. It is also important to say that I think that although, let's say, 50-50 minerals do have their synthetic counterparts, yeah, so compounds that you may form in the laboratory, for instance, to imitate formation of these compounds in the nature. For a very good example is a lab growing of alums. An example of an alum which occurs in the nature is a mineral known as alum K. And this is a naturally occurring potassium aluminium alum. And you can easily grow it in the lab, but to grow it, you need some constituents like potassium sulfate, aluminum sulfate. And how do you get them? Well, you get minerals, which are ores of potassium. You get rocks like bauxite, which is an ore for aluminium. And to end this very first lecture, I would like to you to pay attention to links, which I will paste below this clip. These are internet sources which I kindly recommend because they're commonly updated, so they bear correct information about mineral systematics, mineral nomenclature, also mineral occurrences. You can find plenty of photographs, microphotographs of minerals there, and plenty of other sources, including books. They bear all the information, which, you know, mineralogy, as many other sciences like chemistry, for instance, are changing, are growing. We say Pantarei, yeah. So many names of minerals you might find in books. In mineralogy books, in chemistry books, in physics books, they're non-existent anymore. They've been changed. Some minerals turned out to be mixtures of other minerals, so they're discredited. And also knowledge about the chemical composition, formulas, stoichiometry, crystal structure of some minerals. It's changing, so it's good to follow these sources of knowledge which are updated. Okay, so thanks for watching, and I invite you to follow my movies. If you want to contact me, I also invite you to do that. And thanks for watching again.